Hey guys, welcome back to AlgoYogi. We are doing array and hashing series, and our next problem in the list is range sum query immutable. So let's go to LeetCode. All right. Given an integer array nums, this is a design problem by the way. So let's go into it. Given an integer array nums, handle multiple queries of the following type. Calculate the sum of the elements of nums between indices left and right, inclusive. Now implement the num array class, right? We have to implement this class, and then basically, this function sumRange. So we'll initialize basically the first this nums that's given to us in our num array class, and then we'll implement sumRange function. This is basically the most important function here, which will return the sum of the elements of nums between indices left and right, inclusive. Really simple, extremely simple. So basically, we are given nums. We will be given nums. We will basically store it into our num array class using the same name. We can use the same name. Then we are given all these queries, which will run on sumRange. SumRange, this function we will implement sumRange, and this sumRange will take left and right indexes, and here it will basically return the sum of this range from 0 to 2. So here inclusive. So for this query, basically it's asking from 0. If I mark the indexes here, 0, 1, 2, 3, 4, and 5. So give me the sum from 0 to 2 in second index. So this right here, this is what it's asking. For 2 to 5, this is what it's asking. So this is the sum, and then 0 to 5 it's asking for everything right here. So what we can do is, like, in Python at least, we can just return sum of nums I, the left actually, left, from left to right. Since this is exclusive, so right plus 1. Right is exclusive. It starts at left, and right minus 1 it goes up to. So right plus 1. So this is also a solution, brute force. It takes the time complexity of big of n, right? And there is no space complexity here, because, or there is actually, we can say space complexity is also big of n, and that's because we are storing this into our num array class. Now this is a fine solution, right? You can write this solution and it will work, but we can do better. How? So each and every time what we are doing this, running this sum function, which in itself is of big of n time complexity, rather than, how about I introduce a little more space, and let's call that array an array called prefix sum, which will actually store the prefix sum so far until that index. So what I'm saying is, let's say if I get, if I introduce that prefix sum, I can bring down the time complexity to basically big of 1. I can which is a huge improvement. So let's move. Okay, so let's calculate this prefix sum, and by the way, initially I will just have 0 because I have not seen anything, so I will have 0 in the first index. So now when I go to its first index, so by the way, this prefix sum is going to be its length is going to be 1 more than the length of nums, and that's because we are including 0 as well, and you'll realize why I'm doing that. So now what I'll do is, for this sum, I will add it to basically the sum that I have seen so far. So I will just say, simply this algorithm that I'm calculating is basically prefix sum -1 basically 0 plus the current num is right here. So this is what I'm using to calculate this prefix sum, by the way. So here I will calculate it. So I have 0, and then I will calculate it for the first index. So at this index right here, what is it I have seen so far until this num? What is it that I have seen so far? I've seen -2. That's the sum that I have seen so far. So I'm adding this current num to the previous value. All right. Then I will include. By the way, sorry, I was calculating it for this 0th value. So this is what I've seen so far. Right, inclusive. Now for 0, what is it that I've seen so far? 0 plus -2 is going to be -2. Then for 3, it's going to be -3. Sorry, 3 plus -2, it's going to be 1. Then for -5, it's going to be -4. -5 plus 1 is -4. Then -4 plus 2 is -2. And then for -1, it's going to be -3. So now this prefix that I have right now here, let's say if somebody was asking me, give me the sum of the query, is it from 0 to 0. So left integer is left index is 0 and right index is also 0. So what I'll do is I will return the difference from this right index, this right and left. So right plus 1 minus left. The reason I'm doing it because I had this sum already, I appended this 0 sum so far, which means it means nothing, like basically. So the reason I'm adding this 1 right here is so that I can actually access this 2 right here, -2, because it has to be inclusive. So if I was asking from 0 to 0 and I had to make it inclusive, that is why this will return -2. Sorry, -2. So this will be 0 plus 1. So this will be 0 plus 1, 0 plus 1 minus 0. So which will be 1 minus 0. These are the indexes I'm talking about. So 1 minus 0 would be -2, and which is correct. Okay, so let's calculate it for our queries. So what I'll do is okay, so for this I will do left to right. So from this is left and this is right. So I will do right plus 1 minus left. So 2 plus 1 minus left 0. So these are the indexes. So this is third index, and if I mark these indexes 0, 1, 2, 3, 4, 5 and 6. So third index is 1 minus 0th, at 0th index is 0, is 1. So if you see right here from 0 to 2, if we basically sum all of these, then we will get +1. So this is correct. We can check for this as well, right? So this will be 5 plus 1, 6, 6 minus 2. These are the indexes. So at 6 we have -3 minus 2. 2 is right here, -2, and that will basically give us -3 plus 2. That will give me -1. So if you see in our actual query, the sum of 2 to 5. So this right here, entire thing will give you -1, because you have 3 plus 5. 3 plus 2 is 5, and plus -6. So that gives you -1. All right, you can check it yourself. Like honestly, try it yourself. But this is it. This is bringing down our time complexity to big of 1 for the queries at least, and introducing a little bit of space, big of n, because we are able to do it in the constant time. We are able to calculate this in constant time. So let's write it. Things will become more clear once we have the solution right here. So as I said, I will have a prefix sum array initially with 0. That's what I've seen so far. And for num in nums, and you know what, we'll have to have self dot because it's a class. And for num in self dot num, self dot nums, self dot nums, and this prefix right here, self dot prefix dot append, we are appending the current num plus self dot prefix -1. That's the value you know, it calculated so far, and that is it. And for here it's gonna be very simple. So this right here, right +1, that's what we talked about, minus the same thing but for left. And for left we don't have to, you know, do anything, just left. That is it. That's our entire solution. Let's test it on the example cases if we made any mistakes. Yep, right here for num in self dot nums, do we not have to, yeah, this is like given to us, so we don't have to have self for this. Awesome. Great, so let's submit. And of course this has to be the best solution, because for here, for queries, at least for queries, the time complexity for these queries is constant, right? Constant. So time complexity here is constant, and for space we have introduced this you know, prefix. But anyway, even if we didn't have it, we will have to store these nums as well somewhere, right? All these nums. So that is why, like, we haven't introduced any like extra thing from this brute force solution that we were talking about, which was just you know, have the nums right here and calculate you know, sum of right to left range. So that's all. Let's go to AlgoYogi, mark this problem solved. See you guys later in the next problem. Bye bye.